zero point 0.3. The table on the right side shows regenerated force for different amount of applied braking force and motor speed or vehicle speed. In the first column, for high value of applied braking force and vehicle speed, the regenerated motor force is low, which means when the vehicle is moving at a very high speed and when the brake is applied immediately, then the amount of energy regenerated at that moment will be very low. So the same can be applied to the other combinations as well. Next slide. Here I have the flowchart representing distribution of braking force. In this flowchart, the input variables are braking force and vehicle speed, and the output is a type of braking system implemented based on various if-else conditions in the used in the flowchart. So this will end my PIC component. Over to Apurva.
Okay, so I'll be talking about the factors that are affecting the regenerative braking. So, usually, regenerative braking allows the electric vehicle's range to be extended. However, the efficiency of capturing this energy varies from 16% to 70%, and there's a reason for this. So the reason for the significant difference in efficiency is due to the driver's style of driving. For example, if they brake gradually all throughout the process of driving, their efficiency is going to be much more than the person who waits until the end moment and slams on the brake suddenly. And except for the driving style, the temperature of the system and the atmospheric conditions also affect the efficiency. So therefore it is extremely important to inform and educate the consumers about the different driving techniques so that they'll be able to adjust their techniques to maximize the efficiency of the vehicle energy recapturing system in order to extend the longevity of the battery. And the vehicle size may be one of the biggest factors in the effectiveness of regenerative braking. And the reason for this is that the heavier vehicles have much more momentum and the kinetic energy due to their weight. So, just as a big flywheel is much more effective than a small flywheel, a four-wheel electric scooter has a lot more kinetic energy and henceforth a lot more efficiency in terms of regenerative braking when in motion than an electric bicycle or scooter because it produces a higher amount of electric energy. And the regenerative braking is basically the need of the hour because there's a rapid increase in the world population, and hence and the amount of vehicles being used are also rising. So there are serious threats to the environment and the human health due to various factors such as air pollution and rapid depletion of renewable resources like petrol. So due to this, the and due to the worldwide energy crisis, the nations have been compelled to turn to alternative energy resources and to retain energy from the existing resources. The regenerative braking systems are among these important energy saving applications. And the regenerative braking is mainly used in electric vehicle systems, which have become popular in the recent years due to their fuel economy and minimum vehicle emissions. And here I'll be talking about the future of regenerative braking. So, regenerative braking requires further research to develop a better system that brakes faster, and future technologies in regenerative braking will include newer prototypes of motors that are much more efficient as generators rather than motors. New drivetrains are being planned and built with a better system for regenerative braking. So they're supposed to be built in such a way that they use least amount of frictional braking. And here I'll be talking about the mathematical modeling of regenerative braking for a BLDC motor. So BLDC motor is preferred to be used in an electric vehicle since it can be operated smoothly in comparison to AC motors, and it also has a very high efficiency. So here we make a few assumptions. That is, it is a star connected stator winding with homogeneous distribution, and the saturation effect of the magnetic circuit and the eddy current losses are considered negligible. There's no neutral line, and the effect of damping is also negligible. So here we have a BLDC circuit, that is an LCR circuit, and we use the concept of matrix to construct a voltage equation using various variables. So here we have UAEB UC, which are the phase winding voltage, IAIB which are the phase winding current, EAEC, respective back EMF of stators, and L and M are inductance and mutual inductance of the windings. So yeah, here using the concept of matrix, we have the electromagnetic torque equation, that is 1 by omega into EAIA plus EBIB plus ECIC. Yeah, now my friend will be concluding the topic of regenerative braking.
Coming to the last part of the presentation, RBCs used in vehicles saves a little energy during braking. The latest analysis and researchers show that 30% of energy re-emitted can be recovered. It has huge scope for the conservation of energy. The regenerative circuit stores and returns the energy back to the batteries which would have been otherwise wasted. During the various constraints, the use of regenerative braking system is limited in electric vehicles and is based in a combination of conventional braking system. RBS stores and returns the energy back to the battery which would otherwise be wasted. Regeneration used in combination with anti-lock braking system results in electric vehicles that is much efficient, smoother and convenient to use. This comes to the end of our presentation. Thank you.